Hey everybody, welcome to video 8.3. This is number 2. So as you can see on your outline in this video, we're going to be talking about how to find the equations of all 3 of the altitudes and of course graphing them as a result. So in your lesson page, I'm here at example 1 and just wanted to talk through this example with you before we do another one in actually example number 5. So in example 1, it says find the equations of the lines containing the altitudes and graph them. And we have 3 vertices that were given, 0, 0, 2, 6, and 8, 0. So our first task will be to go ahead and graph those points. And the grid to the right here already has it done for us. Step 1 is going to be to choose then, after we've drawn the triangle, one vertex and find and graph the equation of whatever line contains the altitude from that vertex. So if we were to choose here point P, the side opposite P is side OQ, which is a horizontal segment. And in the examples that we're going to have, at least one of the sides is going to be horizontal, which means that the altitude is vertical, right? So that's the way we're going to find the equation of this line right here from point P. Segment from P is the altitude there. And we can simply do that with finding the equation of any vertical line. And any vertical line, if we trace through that vertical line and talk about where does that vertical line contact the axis, and then which axis is it, it's at 2. So the equation is simply x equals 2, and that's pretty simple. Step 2 is going to be to go through that process again with a second vertex. And so in this case, we're choosing point O, which is the origin. And if we want to draw an altitude from O, it's going to need to be perpendicular to side PQ. So what we want to do is calculate the slope of PQ, and you can see that work just like we did in our algebra refresher video here. Shows us that we have 6 minus 0 over 2 minus 8, and we get a simplification of -1. So you can see as we move from left to right on that segment PQ, it goes down, so that makes sense why our slope is negative. We could also, if we wanted to, draw in a slope triangle here, and it might help you guys to do that just like we did in our algebra refresher video. So here's our slope triangle, and if we count the blocks, 1, 2, 3, 4, 5, 6, we're going a run of 6, but a rise of 1, 2, 3, 4, 5, 6, but a negative direction. So when we think about the slope of, and it's really important to make sure you label your work here, so slope of PQ would be rise over run, rise -6 over run +6, and a negative divided by a positive is why we are able to get that slope of -1. Now remember, what we want is actually the altitude's equation, not this line's equation, but the altitude's equation. So the slope of the altitude is the opposite reciprocal. There are those words again. I'm going to underline this in blue so that we can talk about what that would be when we draw that segment in. The slope of that altitude then is +1. The opposite reciprocal, opposite change sign, flip the fraction. And remember, this is kind of like having -1 over 1 when I think about it as a fraction. So the opposite reciprocal of that would be +1 over 1, or +1. And so that equation, because we are working with the equation y minus y1 equals m times parentheses x minus x1, which remember is our point slope equation. If I substitute in the origin, which is 0, 0, and a slope of 1 for m, then I get that altitudes equation. So that's this segment right there, okay? All right, we only have one more altitude to find. To do that, you guys are going to want to turn the page, and for step 3, we are going to go through this process again with a third vertex. Obviously, the only vertex we haven't drawn an altitude from right now is Q. And remember, Q is going to be coming perpendicular to OP. So we first need to know what is the slope of OP here. And if we were to draw in a triangle here, and I'll draw that slope triangle in for you guys, from O to P is going to be a run of +2 and a rise of 1, 2, 3, 4, 5, 6, or +6. I'm just kind of writing over the top of things, I realize, but we already have the equations of what's underneath there. So a rise of +6 and a run of +2, or if we use the end points of segment OP, either way, we get that the slope is 3. Now again, for the altitude, we want the opposite reciprocal. So remember, this 3 is +3/1. So the opposite reciprocal will have a negative slope, and when we take the reciprocal of 3/1, we get 1/3. So the slope that we are expecting to have for our final altitude will be -1/3. So again, we're going to start with the equation y minus y1 equals m times x minus x1. That's the point slope equation. And we're going to substitute in the things that we know about this line itself. I'm going to draw this line that we are calculating here in blue. We know that we're going through point Q and that we're coming across with a -1/3 slope. Since we are going to the left, we actually are going to run to the left and rise +1 in order to get that correct slope showing for us. And we're going to substitute in the only point we know, which is Q. We don't know where this end point is of this blue segment. We know Q, and we know the slope. So we're going to substitute in the coordinates for Q, 8 for the x1, 0 for the y1, and then the slope that we have, and do be careful, there is a negative next to that equal sign. Hopefully you can see that. And that is -1/3 in place of m. And then we just need to do a little bit of algebra and make sure that we distribute this -1/3 sign throughout the parenthesis here with the x and to the 8, -8, and then just simplify. And so the equation that we're looking at for the segment in blue is right there. Okay? So that's how we go through the example that's already explained for you. Now let's actually do the work ourselves in question number 5. So go ahead and turn there. My map is all the way down here, so bear with me. All right, looking at number 5, find the equations of the lines containing the altitudes and graph them. I'm going to zoom in a little bit. So first off, we want to graph the points, and they are Q, R, and S. So let's go ahead and do that. Our points, I'm going to do this in black, you guys, so that you can see a little easier. For -3, point Q is going to be right there. And 8, +5, going to be right here. And 8, -8, notice we have a vertical segment there. So 8, -8 is going to be all the way down here. And I'm just going to try to draw those lines as straight as I can for you guys. Go ahead and you guys use a ruler, please, okay? Let's see what we can do here. We'll zoom in a little bit. Make it a little easier to draw. So, go like so, and like so, and like so. Sorry about the messiness there. You guys get the idea. Let's make sure that we label our corners. So Q, R, and S. Okay, zooming back out to give us some work room. When we're looking at that triangle, we see a vertical segment, so we know that our first altitude here, coming across from Q, is going to be a nice horizontal line. And a horizontal line is the equation y equals whatever the constant is that it's going to come across and contact the y-axis at, and that's going to be at -3. So be aware, as we have always talked about with precision, we want to label our work. So the altitude from Q has the equation y equals -3. The next altitude that we want to find is the altitude from R. In order to know the altitude from R, we know that we're going to be coming across to QS. And like we talked about in the first video where we were just drawing these, we know that our altitude from R is going to be coming perpendicular to the side that it goes across from. So perpendicular to QS means I need to know the slope of QS. So I'm going to draw in a slope triangle here. I'm going to do this in red to go from Q to S. Hopefully you guys can see we have a run of +4 and a rise of -5. And so the slope of QS is -5 over 4. So therefore, the slope of the altitude from R would be the slope of the perpendicular, and that would be the opposite reciprocal, or +4/5. So we know the altitude from R is going to go through point R, and point R we know is 8, 5 for its coordinates. So as far as the work for this one, we're going to substitute in y. Minus y1 is the y coordinate, so -5 is going to equal 4/5 times parentheses x minus the x coordinate, which in this case is 8. And we'll do a little bit of arithmetic on that. So y minus 5 is going to equal, distributing the 4/5, we would have 4/5 x minus 4 times 8 is 32, so 32/5. And when we think about adding our 5 to both sides, I would encourage you to add actually how many fifths 5 is, which is 25 over 5 that would be equal to that, because you've already got a fraction working on this right-hand side. So -32/5 plus 25/5 gives us a final equation there for this segment coming across from R of y equals 4/5 x minus 7/5. So far we've got blue equation coming across as a horizontal line. Our red equation coming across from segment or point R to segment QS. And now we'll do this part in green, which is going to be our altitude from S. And S is going to come across to side QR, across like so, to the extension of that side, right? And we want to make sure that it, in the same way, has to figure out the opposite reciprocal of the slope it's coming perpendicular to, and that's QR. So that slope triangle, we already have a run of 4 there, but the other part of the slope triangle is going to go right up to R. So positive 4, and that would be a rise of going from negative 3 all the way to 5 of 8. So the altitude from S, remember we want to first of all figure out what is the slope of QR. That slope is a rise of positive 8 over positive 4, a run. So that slope is 2. And so the slope of the perpendicular is negative 1/2 when we think about the opposite reciprocal. And the altitude from S, we want to go through point S. So that's going to be through 8, negative 8. And finishing out, slide over a little bit here, but finishing out that work with point slope form, we would have y minus, now be careful here, the y coordinate is already negative, so this actually turns to plus 8 is going to equal the slope of the perpendicular that we found, negative 1/2, times x minus the x coordinate, which is positive 8. And doing a little arithmetic there, distributing that negative 1/2, we would actually get positive 4. Negative times a negative is a positive. And then moving that 8 over, subtract 8. This one doesn't need any nasty, messy fractions. And our final work here, you guys, is y equals negative 1/2 x minus 4. And that'll be the equation of that segment right there coming from point S. So that's how we find the equations of all of those altitudes. With one more example, in number 6, check in on that, see what you guys can do with it, and then we'll go to our next video.